Hello, this lesson is about linear equations, functions and zeros, and applications. Solutions, just kind of looking at these, solutions have terms which says solution set, and we could have infinitely many solutions or we could have no solutions. And then we're going to solve zeros algebraically and graphically, and then we'll look at our word problems. So this is just kind of taking you through the order that we're going to look at these particular issues in. So first of all, let's get going with our solutions. A solution is something that's going to make it true. By now you have seen me already do this, so we know we use inverse operations and kind of unwrap that variable. So if ever in doubt, you can just think, what would you do to plug in a number and then work in reverse? In other words, if I wanted to plug a value in for x, I would multiply it by 3 and add 2. So that's what I've got to undo in exact reverse. Instead of adding 2 at the end, I need to subtract 2 at the beginning. So again, multiply by 3, add 2 becomes subtract 2, and then divide by 3. So when we solve this, it's just, and I'm going to show every step this time, and I don't always do that. I hope you guys will just get in touch with me if you have questions about where something came from. So we have 3x equals 5, divide by 3, and x equals 5/3. So about that solution set, set notation is that we put braces. So this one is a single value, so we can just put it in braces. But definitely we may have a lot more steps involved than just that. So this one is just a little bit longer. So when you have something like this, what you want to do is collect the variable on each side or simplify each side first, and then we will bring the variables around to one side. So going from left to right, what I can see here is that 6x is a like term with 8x, and then 5x is a like term with negative 7x. So just taking the 6x plus 8x, because everything is hooked to the sign in front of it, then that gives me 14x, just copying over the minus 1. Then 5x minus 7x is negative 2x, and copy over the plus 2. Now we want to get our variables on the same side of the equation, and it doesn't matter if you want to move this 14x over to the right or move 2x, this negative 2x to the left. Most people like to move things to the left. I often do that, but I really, my preference is just keep things positive if we can. So I'm going to add 2x to both sides of the equation. So here that'll go away, and then I have 16x minus 1 equals 2. Now I'm back to that 2-step like I was on the previous screen. So I have 16x equals 3 and x equals 3/16. It's fine if you use decimals as long as you don't round them off unless your instructions tell you to. But generally, we're going to easily get the fraction just by writing it over it instead of actually dividing it out. So that would be our solution set. And again, I've put braces around it, so it's in set notation. But not all equations have solutions, and some of them have infinitely many solutions. And that's what happens when you're solving and your variables just disappear. So using the same approach, if we wanted to solve this, on this left-hand one we have 2x and then plus 3x, because you might not be aware of it, but the parentheses make no difference whatsoever if there's no powers on it and there's only a plus in front. So this is 5x plus 6 equals, now 2x plus 3x is 5x, and then we have plus 4. And some of you can already tell that this is not the same, but I'm just going to work it all the way out. Our next step would be to subtract 5x from both sides of the equation. And the variables just disappeared. And I'm left with 6 equals 4, which is a lie. Math is not supposed to lie. There is no number that is going to make 6 equal 4. 6 does not equal 4. So in this case, this one is a no solution. Now, a no solution can also be written as the empty set is the same. The symbol for the empty set is like a 0 with a slash through it. But I think no solution is what your homework actually has you put, but it might have you put the empty set, okay? But if your variables disappear and what's left is a lie, there's no solution, okay? On the other hand, we're going to have the opposite case happen over here. If I combine those like terms, my left-hand side stays the same. 12 plus 3y equals 3y plus 12. Now that already sounds better. But if you subtract 3y, if you didn't notice, you know, you're distracted that somebody at your house needs something, your phone rings, whatever, and you're not paying attention real close. I hope that's not happening. We get 12 is equal to 12. And that is the truth. But even more than it being true, I think the idea that we get when we see something like 12 equals 12 is, well, duh. 12 does equal 12. That is true, okay? It is true no matter what number you use. It's true if x is -3. It's true if x is 5,000,000,006. 12 still equals 12. So this one has infinitely many solutions. And I am abbreviating it. It is typed out neatly up here, infinitely. But infinitely many solutions would be our final result to that one. So again, if the variables disappear, you've either got no solution or infinitely many solutions. Which one is which depends on whether or not you were left with a true statement or a lie. A lie is no solution. The truth is infinitely many. So your equation can have one solution, no solution, or infinitely many solutions. This is when we're going to have x equals. So you're just going to have whatever number that is. And here, no solution is an empty set. And infinitely many solutions, how would you write that down? Actually, it's generally negative infinity to infinity, and they put parentheses around it because this one is in interval notation. And you've practiced with that some. Okay, so interval notation. One solution is where you just put one number in the list. No solution is the empty set. Infinitely many ends up being the entire number line from negative infinity to infinity when you're solving for x. And that's interval notation. Now, these are the steps, and I've already done this some. Simplify each side of the equation. You want to clear, if they have it, they don't always have it, but if they have parentheses or exponents, then you're wanting to take care of those and then combine your like terms. Like terms is what you're dealing with the most. Then you can clear fractions by multiplication if you want. I think my next slide is an example where I can do that for you. You can see it, it's not required. Then collect the variable and then isolate the variable. Those are the steps that we've gone through. Simplify, collect the variable, and isolate the variable. Whether or not you choose to clear fractions is up to you. Okay, so here, this one, to simplify this, instead of just ignoring those parentheses, I need to distribute. Okay, so that is 7 times each of those terms. So I get 35x plus, and then 7 times 9 is 63. Equals, and this is like a negative over here on this right hand side, that's like a -1 that's in front of the parentheses, and that does make a difference because that gets applied to both parts, like you're multiplying by negative, which changes the signs. So a negative in front is going to change the signs inside that parentheses. So now I need to combine my like terms. I don't have any over here on the left, but on the right, the positive 18 minus 9 is going to combine. So I have 35x plus 63 equals, and then 18 minus 9 is 9, and I have minus x. All right, now we're ready to collect the variable. So I'm going to add x to both sides. Again, I tend to move it the direction that's going to make my numbers be positive if I can. And I'm going to skip drawing that horizontal line since I have real troubles drawing the line on here. But those are going to cancel. 35x plus x is 36x. Now subtract 63 from both sides. So I get 36x equals, and this is going to be negative 54. So 36x, just kind of bringing it back up to the top here with room to write, 36x equals negative 54. And then divide by 36. 36 cancels, x equals, and what I'm going to do, since I know this doesn't go in there twice, but they're both even, I need to reduce. So you can use a calculator to reduce, and if I just show you that on the calculator, I'll show you a quick way to reduce on your calculator. Negative 54 over 36. We'll go back to my mode, which I'm in my regular run screen, which if you're in a screen you're needing to get out, you just need to hit second mode, which is your quit option. And I can put negative 54 divided by 36. Now if I hit divided, it's going to turn it into a decimal. This decimal stops, so that one would be fine to use, but if you get a longer one, what you need to do to get back to a fraction is hit math, enter, enter. And so negative 1/5 is the same thing as the negative 3 over 2. All right, and that's my solution. And if I needed to put that in set notation, I just put that value. So on my previous screen where I had an x in there, you're actually putting in there the number that x equals. All right, so here's one with fractions, and boy, that's a weird looking little negative in front. That is a minus there. I don't know why it's like that, but that's okay. What I'm going to do right now then is I want to combine those, and I could use different approaches. Maybe I'll just work this problem. Over here on this left-hand side, I just did that line just to separate the two. I'm going to work this by multiplying to clear the fractions, which I said was an option earlier. To multiply, if you're going to multiply to clear fractions, what you want to do is look closely at the denominators and decide to yourself what would be the common denominator. And so that common denominator in this case would be 12. So then what you want to do is you want to multiply every single term by 12. So I'm going to do 12 times that term, 12 times 16x, and then 12 times 9. It doesn't matter if you multiply from the front or the back. What that does is it allows you to reduce those fractions so you're not going to have them. So then I have negative 5x. Now 6 will go into 12 2 times, so I've got 2 times 1x, just 2x. And then this one is 108. All right, negative 5x plus 2x then is, but you see I've got my fractions gone just in that one step. So that's the purpose if you want to do that. So I have negative 3x by combining those like terms equals 108. So I'm going to divide both sides by 3. A positive divided by negative will be a negative. 3 will go into 10 3 times. 1 left over. So that'd be 18 divided by 3 is 6. So my solution here is negative 36. Now, if you did not want to do that, then we take the negative 5/12 x plus 1/6x equals 9. So I just copied over that problem again. And what you do is you focus just on getting common denominators. So here the common denominators we've already mentioned would be 12. So I need to rewrite this fraction in terms of that common denominator. So I would leave negative 5/12x plus, and then to get this to be a 12 at the bottom, I'd multiply by 2, and then I need to do it on the top also. So that becomes 2/12x equals 9. So that's the only one I've affected. And then as I go from left to right here, combine my like terms. Since they have a common denominator, you just combine the numerators. The negative 5 plus 12 is negative 3, and that's over 12x equals 9. I could reduce this so that that becomes negative 1/4 x equals 9. And then to solve that part, you can multiply both sides by negative 4, so that negative cancels and the 4 cancels, or you can divide both sides by negative 1/4. It does the exact same thing. So what I'm going to do is I'm going to multiply both sides by negative 4, multiply by the reciprocal. So I put parentheses so it looks like multiplication, not subtraction. Okay. Then my negative cancels out with the negative, the 4 cancels out with the 4, and x, 1x, so that's just x, is equal to negative 36. You get the same answer both ways. The question just becomes, which one did you understand the best and which way would you rather do it? So if you want to multiply to clear fractions, then you decide what your common denominator would be and then multiply every single term by that fraction. By that common denominator, excuse me. All right, so moving into another topic, zeros. Zeros are a special type of solution. The zero of the function is the value of the variable that makes the entire function equal 0. So you know, math people, we're always very creative there. So since it equals 0, we call it a zero. Now, I know that that can be a little confusing when you're listening. So equals 0 is one thing. A0 is the number that makes that happen. X is A0 if f of x is equal to 0. So when you're looking at a graph, don't forget that f of x is a y value. So x is a 0 if it makes y equal 0. And when y equals 0, that's the x-intercept. Okay, so the x-intercept happens at some particular value, and that value is a 0. So looking over here at our graph, this x-intercept occurs right there at 2. So in this particular case, we're going to say that since the y value, or since f of 2, which is that y value at 2, is 0, 2 is A0 for f of x, or of f of x. It's just a little bit of different terminology, but you've just got to get the x-axis, okay? So 2 is a 0. So now we have a new word, and they can use this new word in your questions. So when we look at this, one of the things is just how they write the questions. You know, I've had students many times say, I think I could answer the question if I understood what they were asking me. So there isn't just vocabulary you have to pick up. The x-intercept is often written as a point. So the x-intercept is where it crosses the x-axis, and so we see that right over there at 4, 0, and that's our x-intercept. Now, what is the 0? What is the number that makes it equal 0? the 0 is 4. Okay? Now, we could also say, I'm going to back up 1 second here, x is a 0 if f of x equals 0. Okay? So 4 is a 0. Now, what is the equation f of x? Now, that's a little bit different on here, but what we can do is, again, use our movement to determine slope. So if we go vertically and then horizontally across those lines, what we find is that we need to go down 5 and to the right 4. So that would mean the slope is negative 5 over 4. But the x-intercept, not x-intercept, the y-intercept is what we need to write the equation. Remember, that's the other thing you need. And you can see that over there. The b value of that y-intercept is 5. So when I want to write the equation, it's y equals m x plus b. So I've just filled in those numbers there. Now, what is f of 0? F of 0 is what you get when you plug in a 0. So if I plug a 0 in right here, then what I find out this equals is 5. It doesn't equal 5, but when I plug in a 0, I get 5. So notice V0 is different than f of 0. And you just have to pause and get this straight, you know, however you're going to have to do it, because I find that whenever somebody learns something, one of the things you have to do is just learn, how am I going to remember this? Looking over here at your graph, when the x is 0, you get 5. So f of 0 is equal to 5. But on this other one, 4 is a 0. Since f of 4 equals 0. So you've got to get those, just new terminology, but you've just got to slow down and get it straight, okay, as to how you're going to remember it. All right, so moving over into our application problems, which I did mention is how we talk about word problems now, because really it's not just words that mean nothing. They apply in some way to life. And sometimes you might run across a word problem and you think, I don't see how this applies to my life. But sometimes life is more complicated than the word problems we're giving you also. Really, though, we can use linear equations and solutions and things along there a lot of times to find out how long is that going to take, how much is the profit, or how much is that going to cost me? And those are 3 big questions in everybody's life usually, how long and how much. So let's look at a couple of application problems, okay? Now, this seems very practical for people enrolled in GNTC. To finance community college education, Sarah takes out a loan for $2,700. After a year, she decides to pay off the interest, which is 6% of $2,700. How much will she pay? Okay, well, we know that our interest is 6% of the money that she took out, $2,700. So that, I don't know if you would remember this or not, but a lot of times of is going to translate to multiplication in math. So the work you really need to do is this one, okay? 6% of that, I just changed that to a decimal. Now, I don't expect you guys to do that in your heads. I might could figure it out, but why use the time for that? 0.06 times 2,700. I just picked up a little basic calculator here. Is 162. So how much will she pay? $162. And you might ask yourself, that didn't seem like the algebra we were doing earlier. But the I was a variable. Anytime you have an unknown, it's a variable, so you just solve for that variable. Now, an airplane that travels in still air, 550 miles per hour in still air, encounters a 50 mile per hour headwind. So if you're going into a headwind, it is slowing you down. Okay? How long will it take the plane to travel 900 miles into the wind? Well, its normal rate is 550, but it's getting slowed down 50 miles per hour essentially there. So one of the things you might need is to know how do you calculate rate and stuff like that. So I'm going to come back and work that problem with the airplane, but I just wanted you to see this screen for a minute. You can look up a lot of basic formulas. In this particular homework, these are some formulas that could be helpful, where distance is equal to rate times time. That's the one we're about to use. The amount owed, so I know it doesn't say this, but the amount owed is equal to the principal times 1 plus the interest rate times t as a number of years. Okay? Area is equal to length times width, and the perimeter is 2 of the lengths plus 2 of the widths if it's a rectangle. However, if you're working other application problems and you don't know the formula, you're just going to have to do a little quick Google search probably of, the formula for. Just type that in to see what it is. But the distance is equal to rate times time. That's what we're going to go back and use over here. Okay? Distance is equal to rate times time. Now, how long will it take is the question. So t is going to be my variable. 900 miles is the distance I need to travel. So 900 miles for the distance. My rate would have been 550, except for that headwind is slowing me down. So it's effectively 500. Okay? Now, in this problem, these are in good units, is that this one is in miles, and my rate was in miles. But do watch for things like that, because you can't use something that's in inches while something else is in feet. You have to get them in the same sort of units. So here, 900 is equal to 500 t. Divide both sides by the 500. Weird looking 5. Okay, but that cancels. The zeros over here are going to reduce out. And don't forget that's a 5. It kind of looks like a 6, doesn't it? Okay, so we end up with t is equal to 9/5. But in this case, that is not a practical answer. Nobody wants to be answered like that. How long is it going to take us to get there in the plane? Oh, 9/5. So you need to answer it in a way that's practical. So what I'm going to do is, first of all, I'm going to change that to a mixed number. That is 1 4/5. And then I'm going to add units to it. Units is what this was measured in. So time, what were we measuring time in? Time was being measured in hours, as you can see up there at the top of the screen. So 1 4/5 hours. Now, that's not a bad answer, but it might help to know how much 4/5 of an hour is. So what I'm going to do is 4/5 of an hour. If we multiply that by 60, then we will figure out how many minutes that is. So that's 48 minutes. So I could have said it's going to take about 1 hour and 48 minutes. And that's where the pilot can come on. Hello, thank you for flying with us. We'll be in the air, or we're encountering a 50 mile per hour headwind, and our travel time will be extended somewhat. We'll be in the air about 1 hour and 48 minutes. All right, again, these are those formulas that I think will be helpful to you. You might need some other ones, might not have them all there. Hope everything goes well. Get in touch if you need some help.